So in the last lesson, we added in our Babel loader so that we can convert our JS and JSX files down into ES5 JS files that our browser can understand. What we're going to do now is we need to actually bring in another loader because we need to actually tell Webpack what it should do with CSS. It actually doesn't know how to render and bring in CSS yet. This is a thing that we have to do with Webpack. What we're going to bring in is two new loaders. One loader is called the style loader, and the other loader is CSS loader. Now, style loader is what allows it to convert different types of style files. The style loader actually allows us to import in style files into our React component files. The actual CSS loader is what converts CSS into a version, or not even a version, but it's just what allows the CSS to be read by our JavaScript files. We can use a Sass loader if we wanted to convert Sass over as well, but you always need CSS loader and style loader. So we're just going to bring those in. Style loader as well as CSS loader. Now that we have those two loaders in, we're going to define a new rule. And here we want to say that for any file that ends in CSS. So just like our JS, it's following the very same conventional pattern. Except we don't need these brackets because we need the brackets when we want to do the or, but we don't here in this context. We want to say for any CSS files, we want to just run them through the two loaders. And use can take an object with multiple options, or it can take an array. And here we're going to pass an array because we want it to run through two loaders. Keep in mind here that the order does matter. Loaders evaluate from right to left, and we want to render the CSS loader first before we do the style loader. So because we're going right to left and we want style loader to be last, we're going to say style loader first and then CSS loader second. And that's all we need for CSS. The last thing that we need to do is we need to make sure that we can output and build a HTML file that we can actually finally read in our final production build. In order to do that, we need two more tools. So going back to our terminal, we are going to add in HTML loader, which as you're familiar with now, it's simply just a loader, but we also need HTML Webpack plugin. So the HTML loader is the thing that lets us read our HTML file inside of our React application. But the Webpack plugin is what allows us to actually place the output somewhere. So what it's going to do is it's going to build all of our HTML files and it's going to create efficient chunks as we saw in our performance optimization courses, where they're the HTML bundles with the JavaScript for each page. And this plugin actually helps us do that. So here we're just going to add these two libraries. And once we have that, let's go back to our rules and let's add another one. So here what we want to do is we want to say, in order to use our HTML plugin loader, it's pretty much going to be the exact same as what we saw with the style loader and the JS loader. We need a test. And just as we saw, we're going to write that we're matching anything that ends in .html. And then we're just going to use the loader HTML loader. So as simple as that. The only thing now is that after rules, we have to actually bring in that HTML plugin that we were talking about. So there's another property called plugins. And inside of plugins, we're going to call new, and then we got to call the actual plugin. So we got to bring that plugin into our Webpack config file. So we're going to say const HTML Webpack plugin is equal to require HTML Webpack plugin. So we're bringing it in here. We want to instantiate an instance of it, and we're going to pass to it a configuration object. This object is simply going to take the template of the actual file that it's going to use as the index.html starting point in our React application. So we wanted to take this one that we have in our source because this is the one that renders the div ID of root. Using the app.js code and all of the index.js code that we have here, what's going to happen is that inside of Babel loader, Babel loader always by default tries to go for a index.js file inside of your source folder. That's why we always define index.js inside of source. So it's going to find this file, it's going to run this code, and it's going to use that index.html file that we supply to the actual HTML plugin as the file that it needs to run the JavaScript on, which is where we're going to end up using our React DOM.render in order to replace that div with the ID of root with our app component. So it's actually the combination of those two loaders together inside of our Webpack that ends up producing and providing outside the new JavaScript and HTML files that we need for our final build. So finally, with this template, we're just going to pass it the string to our index.html. And this is our Webpack config. A lot of new concepts, but honestly, if you think about what it is that we wrote, it's actually quite simple. We're just following along with some simple rules and using loaders. It's just all configuration with Webpack. That's really all it is. Of course, I'm going to link all of the documentation for this so that you can see what other options you have, understand a little better what else you can do with these different options. But this is just a bare bones setup so that we can run our Webpack and render our React code. Now that we have all this, let's just run build, because we've got our config set up. We've got Webpack. Well, it looks like we have a little error here. Oh, I put this in the wrong place. This should be one lower. So plugins comes after module. And now let's try this again. So it's going to run the Webpack build. Can't find app inside of app. Ah, this is a syntax issue. So inside of index.js, this should be app.jsx. Because our loader is looking specifically for this, it does not default. So that's actually one of the things with Webpack. Let's fix that. Let's try this again. So my autocomplete will automatically try and correct sometimes without doing the .jsx, as you've seen throughout this course as I've imported multiple files together. So this is just one of the caveats and nuances with Webpack. If you want that feature, you actually have to write it yourself as a config option. But now we finished our build. But let's actually go over what just happened. We ran into a couple of minor errors. This is very normal with configuration of Webpack. This is why the Create React team and actually many CLI tools, even for Angular and Vue, try and hide this away from developers, because it's so error prone. There's so many little nuances you can miss with Webpack that it's really frustrating to work with in that sense. That's not to say that it's not worth learning. It definitely is worth learning at least what's happening. But the tools, as Andre mentioned in an earlier lesson, an entire team is dedicated to helping you build and set up your configuration with Webpack and Babel to the most optimized degree possible. It's worth knowing what's happening under the hood, at least like demystifying what Webpack and Babel do. But writing it from scratch could bring you a lot of headache. And the configuration options are pretty much just things you have to do by memory and looking at the actual configuration. There's no real logic beyond what it is that each configuration tool is trying to do for you. But now that we have our final build, we see that it succeeded. Inside, we now see we have this new dist folder and an HTML. So let's actually open this, not in the terminal, but let's open up our index.html. Let's reveal in Finder, and let's just open it up in our browser. And there we see our component rendered, our React is working, so we know that our loader is working, and we know that our Webpack is all working. And that's pretty much it. This is all Webpack and Babel do. It transpiles it down, it builds it into a final index.html as well as main.js bundle that we download as we saw in our performance section. So this is actually what's helping. Webpack is helping improve our performance by bundling these files for us when we make these requests. That's why we included the HTML bundle. This is the main advantage of Webpack. Webpack allows us to increase our performance because it sets up a lot of these things for us. The React team by default assumes and must use Webpack. All of these new technologies and frameworks all leverage Webpack under the hood to help them optimize their performance and build the code that you write in Angular or in React down into a readable version for browsers. But now that we finally have our Webpack and our configuration options, we understand what it is that Webpack does. Dig around with the documentation, play with it a little bit yourself if you want to, for example, include the Sass loader. I can include a link to the Sass loader. Just try and follow the instructions and see if you can fit it in. Write a Sass file and see what happens. So hopefully with that, you understand at least conceptually what Webpack and Babel do. That's not to say that for your projects, especially when you're on a new team, that you suddenly write this yourself from scratch. If you also want, you can create a new Create React app application, eject it, and look at how complicated that code is. Because now you at least have a better understanding of what it is that Webpack is doing. Look at the Babel RC as well and see how many configuration options there are. Compare and contrast that with the documentation, and you'll at least see all of the available possibilities that you have in front of you with Webpack and Babel. So hopefully you've enjoyed this lesson, and I'll see you in the next lesson.